Hey guys, Mr. Marone here. Welcome back. We're just going to do a quick video to add on to yesterday's discussion or the last video's discussion on proportions and using side-splitting theorem, angle bisector theorem, and Pythagorean theorem in similar triangles here. And we're just going to take a look first at an image that's at the top of page 22 of your notes. And there are so many proportions in here that I want to just indicate that we've got. Using that side-splitter theorem and using all those other theorems that we've looked at, we've got a bunch of sets here. I have 5 sets of proportions on my own written down here. So I can say that AB over BC is equal to AG over GF. We can also say that AC over BD is equal to AF over GE. So I've got a couple there, and I'm just going to keep working through these. I've got BC over BD is congruent to GF over GE. I've got BC over GF is equal to AC over AF. I've got AD over AE is equal to BC over GF. And there are other combinations you could have. You can have them written differently. There's so many of them. But the idea is that, say for instance, AB over BC is congruent to AG over GF. That those pieces are proportional based on that side splitter theorem. So I'm going to have you guys complete the example just below that. They give you a picture of 3 sets of parallel lines with 2 transversals. And they want you to complete the proportions. So I'll give you a second to answer these. I'll pause the video, and when you come back, we'll quickly explain it, and then we'll move on to some more algebraic approaches. Okay, welcome back. So you can see that I've written in the answers here. So for our first one, they used between the first and second parallel line over between the first and third parallel lines. So we can do the same thing between the first and second over the first and third, and that's how I ended up with TE. And we're going to follow the same process here for these other ones. They gave us that AY from the point down at the bottom to the second line over AM, which is point over second line on the right, is the same as first to second, so it would be over first to second EM. We're just following our pattern when we set up these proportions. And our last one, it has TE from first to third over BD, first to third, on the left, so right to left, first to third. And then I've got something over AD, which is vertex to that bottom one, so it would be vertex at the bottom on the right, AE. Now we're going to use this idea to find these missing lengths of these figures. I'm going to do the first one, and then I'm going to pause the video and let you do number 2 and 3. One thing to remember here, if you notice there are decimals all over the place, don't be afraid of decimals. That is perfectly fine. So our first one, I'm going to stick with the left side over the left side. So 5 over x is equal to my right side 6 over 4.5. And once we have our proportion set up, we're going to cross multiply here and solve out. And you should have, when you do that, x equals 3.75. And these are centimeters here. So I'm going to pause the video, let you guys try B and C, and then when you come back, there will be answers posted. Okay, welcome back. So the second one in the middle was quickly left side, right side, knowing that I have to ignore that 2.5 since I don't have a value over here in between my parallel lines. And we ended up with 4.8 centimeters. And on the right-hand one, you have a couple different ways to do it. If you notice, I have this 4 centimeter located up here, just using segment addition. If the whole distance is 9 centimeters and they gave me 5 centimeters, I would subtract to get 4. And I set up my proportion left over left, top to bottom, just like I did in the other ones. Now, another option you could have done if you wanted to use the numbers on the right-hand side but not subtract or anything, you could set up a proportion of x over the whole length here, which would be x plus 6, and that would be equal to 5, it would be, I wrote this one backwards here. We would be able to compare these two bottom ones, 6 over 5, and that would be what we could place with this x plus 6, so bottom, and then the whole length over the whole length. And if you solved out, you would still get 4.8 centimeters. I stuck with the easier one in my opinion, and I just felt like it was a quicker method to solve out. So we've got a couple other ones to look at. The first thing we're going to look at here are some of these side splitting ones, and you have to be careful with this one. Be careful with this first one, which is on the right-hand side, the top one on your paper. If we were to redraw these figures out, I've got my smaller triangle up here with a 7 and a 5, but my larger triangle, be careful, it is 21 if I add those together over x, not 14 over x. I have to combine the two, so be careful. Your setup should be 7 over 21 equals 5 over x, or some equivalent proportion, and you get x equals 15 centimeters. Just be aware that it is not something like this. 7 over 14 equals 5 over x. We couldn't do this because of the distance on the left-hand side. If we were working here and here, we would be perfectly fine. But because we're dealing with the whole length of a side of a triangle here and here, we need that whole length for our bottom measure, which gives us that 21. So just keep that in mind. And we're going to do that same setup over here. I'm going to use my smaller triangle on the top. So I've got 8 over 6, this 8 over this 6. And that's the same thing as this whole length, 14, over the whole bottom, x. And when we cross multiply there, you should have x equals 10.5 centimeters. Our last example is when we use angle bisectors. So we said this angle bisector created a proportion left to right. So I can say that 6 over 4.5 is equal to 10 over x. So long side over short side, long side over short side. And when you cross multiply, you would get x equals 7.5 centimeters. So try some of these problems tonight in your homework. See if you can come up with answers, and we will review these in class tomorrow.